Hi everyone, so in this video, let us talk about the first three problems from the latest Leetcode weekly contest 322. So let's start. The first problem is circular sentence. So let us go to the problem statement first. It states that a sentence is a list of words that are separated by a single space. As you can see here, these are different sentences. Now, a sentence is called singular, or sorry, not singular, circular, if the last character of a word is equal to the first character of the next word, and the last character of the last word is equal to the first character of the first word. Let's take an example of this to understand that. What you can see is that these are different words. Okay, these are words. Now, for these words, what you can see is that the last character of the word should be equal to the first character of the next word. So these are equal, as you can see. So this E is equal to E, this S is equal to this S, this D is equal to this D, and the last character of the last word, that is this, is equal to the first character of the first word. So this L is equal to this L. I hope you understand the word, or actually the whole problem statement itself, that this is what a circular sentence look like. Now, this is not a circular sentence. Why? Because see, this last L is not equal to this capital L because it is case specific. Though they both are L, but this is small l, this is large L, so these are not equal. Okay, so that's the overall idea that you have to use here. That you have to like, you just are given a sentence and you just have to check that whether it is circular in nature or not. So you have to just do whatever is asked in the problem statement itself. Just take all these words one by one and just check out that for a current word, whether the first word or first character, sorry, of this current word that you have is equal to the last character of the previous word, and you will keep on checking that for every character. Just check out that, and for the last word you will just check out that the last character of the last word should be equal to the first character of the first word. Okay, so these are different conditions that you just have to check that. Let us talk about that. That's the overall code. What we'll have to do is that we will first make a vector to store out all these words one by one, and then we'll implicitly push a space at the end. Like, what is this for? Let's take a small example to understand that as well. What you can see here is that, let's take this as a, you can say, a sentence. Now, how we can determine that a particular word is completed? What you can see is that we have some characters, and then when you find out a space, you can see that there's a space, which eventually means that we have completed a particular word. So a word is completed here, hello, then a space is there, so which means that hello is a complete word. Then the next word is world. How we can know that? By the presence of a space. Okay, similarly there's a space, but for the last word there is no space, which eventually gets us a problem because we have to explicitly talk about the last word again. But what you can do is that we can just like explicitly just like insert a space at the end so that we can do a generalized version of iterating over every word one by one. I hope you get the point here. Let's talk about the code now. So we have inserted a space at the end just for the last word. Now we are iterating over, okay, the characters one by one, moving from left to right. And then what we'll do is that if we find out any character that is not space, then we will keep on building the word, because the word is keep on building. Every character we will take an insert inside the word, and if it is not a space, then we'll keep on repeating. Whenever we find out a space, which means that a complete word is completed, okay, a word is completed, then what we'll do, we'll have to compare the first letter of that particular word with the previous, like the last letter of the last word, the previous word. So what we'll do is that we will take out the previous word using this. So all the words are stored in this, you can say, vector of words. So we just have to first check that the words array, or like you can, sorry, vector should have at least some words inside that. We take out the last word, and then among those last word, we'll check out that the last character should be equal to the first character of this current word. If they're not equal, return false, that this is not a circular sentence. If it is, then it will not hit this condition. Then what we'll do, when we have found out that this is a circular word, then we will push that particular word also in this, let's say, vector, and go on with the next word. And in the end, we have to check out for the last, you can say, for the last word, like take out the last word of this, you can say, words vector, and the first word. and we just have to check that the last character of the last word should be equal to the first character of the first word. If they're also same, then return true, else return false. And if all the conditions are met, then return true. Very simple. That's the logic for this particular problem. Let's move on to the next problem. So divide players into teams of equal skills. Okay, so let's talk about this problem. You are given a positive integer array skills of even length n, where skills of I denotes the skill of the ith player. Okay, so you are given an array as you can see here, and every element denotes a skill of like every player. Now you have to divide these players into n by 2 teams of size 2. So which eventually means that you have to divide all these players into teams of size 2, as you can see here as well, such that the total skill of each team is equal. Whatever teams you have built, these are different teams, the total, as you can see, like 5 plus 1, 2 plus 4, all of them should be equal. Like all of them are equal to 6. Now, the chemistry of the team is equal to the product of the skills of the players. So the chemistry of a team is equal to the product of these players' skills. So as you can see that this is the chemistry, that is 1 into 5. This is 2 into 4. So you just have to return the sum of the chemistry of all the teams. So as you can see that the chemistry of the first team is 1 into 5 plus 2 into 4 plus 3 into 3. The total is 22. That's the overall problem statement. I hope you got the point here. Now how will you do that? And if there is no such division, you have to return -1. So for particularly dividing, and as you can see that it is given that n is equal to even, you can easily divide that. But you have to ensure that when you divide this n, like whatever n is given to you, into 2 teams, let's say for this it's 6. 6 divided by 2, it is equal to 3. So you will form 3 teams. Now you have the total sum of all the elements. You can directly just do a for loop over all the elements, and you can get that the total sum, whatever the total sum is. For this it is 6, so I think so it is 6 to the 18. It will be 18. Now what you can understand is that if you add all these elements, it should be 18. Like if it is 18, I'll divide 18 by 3, it turns out to be 6. Which can directly help me to know that every team should be having a total of 6 elements. Like a total of 6. Why? Because I can easily divide them. If the total is not divided equally, like evenly between 3 teams, then I am not able to do that. So first condition is that the total sum should be evenly divided among all these n by 2 teams, like a total n by 2 teams. Okay, that is the first condition. If it is not, the answer is already -1. Okay. Now, if we are able to divide them into like n by 2 teams, what eventually we have to do? Now, what you can know is that I know that the total target, the total value for every team is. How I can know that? The total sum I have, let's say total is total. And number of teams I have is, let's say, n divided by 2. So if I divide that, I can directly get the total sum, okay, the total score every team will be having. Now, what you can see is that for every element, I can know that if I want to make a team like a person, a team with 3, then, and I want a total score of this, the other element I will be wanting is, let's say, 3 only, because I want a total score of 6. I have 3. So the other person also should be a power, like should be equal to 3. So what I can actually do for this overall operation is to make a map. You can make a map easily, and then whenever you, let's say, you see a number 3, you know that I have taken 3 from the array. Now the other element I will be taking should be equal to score minus the element I have taken, that is 3. Okay, and I can only take that if it is already present in the array. So I like whenever I take out elements from the array, I will like take it out from the map itself. I'll show you in the code part. That's the overall logic that you have to use, and eventually when you're making out pairs, you will keep on like finding out the chemistry, that is multiplication of those numbers, and just keep on appending the total answer. That's the overall logic for this particular problem as well. Let's move on to the code part to understand it more clearly. So what we have done here is that we have taken a total that will show the total sum of the chemistries of all the teams. And what we'll do is that we have taken a map here as well. It treated over all the skills, and we have done 2 things. We have summed all the skills and inserted all the skills inside the map also, which eventually help us to understand that how many values are there of total skills eventually, like how many skills are present. Now in the end, what we'll do is that how many teams eventually we have to form. Skills array divided by 2. Now our main objective is that I can only move forward if the number of teams can evenly divide the score between them. So if the total sum of all the skills If it is a multiple, you can say like if mod teams is not equal to 0, which means that they are not able to divide them, the answer is -1. If they're evenly dividing them, like the score is evenly dividing among all of them, then the answer is like we will keep good to go. Now what we'll do is that the total score that we have to take for every team will be total divided by teams. Teams, that is n by 2, you can say. Okay. So we have now got the total score that we have to require for every team to be satisfying. Okay. To evenly divide all the total skills among all the teams. Now what we'll do is that this is the total answer like the total answer that we have to print, the total chemistry. So what we'll do is that we'll do a for loop, and then let's say that I am at any random positions. Let's say this is an array. Okay, there is some number, let's say. So if I want to take this number and make a team out of it, we have to ensure that this number should be in the map first, because map actually holds the current state, what elements are taken, what elements are not taken. So let's say if I want to take this element, I have to first check that this particular skill, ith skill person, should be in the map. If that particular, like you can say, occurrence is greater than 0, if it's present in the map, I understand that this is present inside the map. I have taken that into the team, so I will decrease it by 1. I decrease it by 1, then what I'll do, I'll find out the other person that will form the team with it. So other person can be formed out by score minus this particular score value. After that, I have to ensure that if I want to make that person also with a team with this particular person, I have to ensure that this should also be in the map. So if that particular other person frequency should also be present inside the map. If they're present inside the map, then both the persons are present. So what I'll do is that the total, like you can say, chemistry or total score will be incremented by add plus equal to the current skill person and the other skill person. Okay, total multiplication of that. And because I've taken both of them, what I'll do is that I will subtract out that particular other person occurrence also from the map. So these occurrences are removed from the map so that I will know that whether I will take that person in the team or not. Okay, and yeah, and let's say that I have taken a particular person, like let's say I have taken a particular person and the corresponding to that person is not present, that person is already taken or that is not present, then I will already put -1. Why? Because let's say I want a total score of 6 for every team and one person is of, let's say, 5, and there is no person of present equal to 1. There is no person present which is having a total skill of 1. Then I cannot move forward. Why? Because I want that the total skill of every team should be equal to 6, the total skill. But if one person has 5, there should be one person which is equal to 1. If there is no person, then this team cannot be formed and this team cannot be formed. So this is actually wrong. I cannot move forward. So answer is -1 in those scenarios only. Okay, and that's it. In the end, we just return a total answer, the total sum of all the chemistries, because we are adding out these chemistries here. In the end, we just return the total chemistry. Okay, that's the overall logic and the solution for the, you can say, second problem. Let's move on to the third problem. The third problem is minimum score of a path between two cities. Okay, so you're given positive integer n representing n cities. These cities are formed using you can say roads, and these roads are given to you, and the roads have some weights also associated with them. So let's move on to the actual problem. Yep, this is these are bi-directional roads, so you can move in any, like, both the direction. Okay, the score. Now just start reading here from here. It's important. All of this is very important. So what you can say is that the score of a path between any two cities, the score of a path between any two cities is defined as the minimum distance of a road in this path. So whatever is the minimum distance value among all of those is taken as the score. Okay, we're not talking about the minimum total distance, no total minimum. It's just the minimum distance, like a small distance. I'll give you an example. So you have to return the minimum possible score between the path from 1 till n. So from the first node till the nth node, n is also given to you. From 1 till n, you have to find out what is the minimum score that is there. Okay. So now these three nodes are very important. The first thing is that a path is a sequence of road between two cities, so you have to move along these roads. It is allowed for a path to contain the same road multiple times. So you can iterate over the same road multiple times. So let's say I go here, again here. I can iterate over the same road multiple times. And you can visit the city 1 and n also multiple times. Which eventually means that if I want to, let's say, go from 1 till 4, then I could have, like, let's say, go like this: 1 to 4, then 4 to 2, 2 to 4, and again from 2 to 1. This is also fine. Okay. The overall idea is that I should not be like, this is not key. I cannot travel the same city or the first city or end city like only once. I can travel it multiple times also. Okay, that's the whole problem. And next is that the test case generated is such that there should be at least one path from 1 till n. They might be like there might not be paths among all the cities, but there will be at least one path from 1 till n. Okay. So let's talk. If you just look over the examples only, you will understand the actual problem. Let's take a look at this. What you can see is that if I want to go from 1 to 4, n equal to 4, okay, what you can see is then the answer for this is like I can go from here, and the path I have taken is, let's say, 7 only. If I take go on from here, then what you can understood is that when I've taken this path, whatever is the minimum value, like we can say minimum weight among any path that are taken, like the minimum. So if I've taken this path or if I've taken this path, whatever is the minimum, that is the actual score. So if I've taken this path, this is 9 and this is 5, the minimum is 5. So answer is, so this path, so let's take that. If I've taken this path, the score is 7 because there's only one. If I've taken this path, the score is minimum of all the weights that I've touched throughout this whole process. I've touched 9, I've touched 5. So the score for this path is 5. So I can take any like route you can possibly take. Okay, I can go like this as well. I can go from you can say like in this direction, that is 9, then 6, then back 6, then go to 5. Okay, I can take any path like this. So again, whatever is the minimum I have touched throughout this process of minimum weight, that's the score. The score is still 5. So among all the different paths, the minimum value I've encountered is 5, and you have to just print out that. Let's take the second example. It will become more clear to you. Let's take this example. I have to go from 1 till 4. Now you might be thinking that let's just go directly here. No, because if I directly go there, the minimum I have touched here among the paths is 4. But what you could have also done is that you have first traveled to here, then go, like you have to travel back, then go here, and then go here. In this scenario, you have touched a weight that is 2, and the score becomes much lesser. I hope you get the point. That's the whole idea, that you have to touch the very minimum. Now, if I can travel the same city again, if I can, so which eventually just means that I have to just touch the smallest one among all the paths that is given to you. I just have to touch the one that is of the smallest weight. So I have to also ensure that if I have to go from 1 till 4 in any path possible, whatever is the minimum weight I can touch, that's the answer. I hope you get the point. So what you can first do is that given the complete graph to you, you have to first, let's say, do any BFS or DFS over this whole tree, which eventually just help me to know that what all roads you can take. Just iterate over and get to the whole tree, which eventually just mark out from one, just from one, go to every other node, like go to every other node, let's say, because there will be obviously one path from one till n. So I can go to any node from one which is connected to one. If like this is connected to this one, this is connected to this, like if there is multiple more, there are multiple modes. So I will just do a DFS or BFS, what I can do, and I will mark out all the nodes which I can travel from one. Okay, let's say that there is one point that is not connected to one. Let's say like this. This is one, this is, let's say, 2, this is 3, let's say this is 4, this is 5. This is another part. I cannot travel to 4 and 5. So what you can do is, in this scenario, I will just leave it. So I will start a DFS from 1 and mark all the nodes that I can travel from 1. And among all those particular nodes, I will find out what all paths I've taken. And among all those paths, you will find out the one path that is the minimum among all of them. Because I will just touch that minimum. And then after touching that, I will just go to my current. So I will go from 1 to that minimum smallest path, the weight. And then from that weight, I will go to the final destination I want to go to. And the total score will be that minimum score. I hope you get the point. That will be the minimum answer. That's the logic that you have to use to particularly solve this problem out. Nothing much, any complicated theorem here as well. So we have to first make this complete adjacent matrix, adjacent array, sorry, to just do this whole traversal over this DFS. So what we will do is that we'll push back, because of bidirectional array, to just going from 0 index, like there's a road from, let's say, node U to node U to node V. So 0th index to 1, and whatever the weight of it. So it's a bidirectional. So you will just do a bidirectional. entry of that, and then I will just do a DFS from the like node 1. This is this. To just mark out all the nodes that I can travel from this particular node 1. After marking out, what I can do is that I will just iterate over every particular, you can say, road possible one by one. Okay, and I will check out that if it is not visited, I cannot reach that particular node. It is just waste to me. If I can reach to that particular node, I will find out whatever is the minimum among all of them. Like, which means that if I can visit that particular value, I will find out the minimum among all those that are connected to it, and I will just print out the answer. That's it. That's the overall logic and the code part for the third problem as well. If you still have any doubts, you can mention in the comment box for this particular video. I will see you in the next one, like coding, and bye.